Welcome back to the deep dive. Today, we're tackling something absolutely essential if you deal with information, which is basically everyone, right? Data visualization.
Right.
You know that feeling, staring at a massive spreadsheet, rows and rows of numbers, just gives you a headache.
Pure noise.
But turning that noise into one clear, powerful insight, that's the goal. That's the superpower we're talking about.
Exactly. And our deep dive today is all about the strategy behind that transformation. It's not just about, making things look nice. It's about picking the right tool for the specific job.
Like a mechanic.
Precisely. Our sources really emphasize this. If you pick the wrong visualization, say, you try using a pie chart to show a trend over time.
Oh, cringe.
You just create an instant barrier. Doesn't matter how good your data is, nobody's going to understand it clearly. It's like using a hammer on a screw.
So our mission today is to break down the core strengths and maybe more importantly, the fatal flaws of about 8 key visualization methods.
Yep. We're starting simple, comparing categories, and then moving up to more complex pattern spotting tools.
The idea is to help you match the chart's complexity to your purpose every single time, aiming for strategic clarity.
Okay, so let's dive in. Where does most data start? Usually with categories. Discrete groups you need to compare.
And for that, there's one undisputed king, right? The bar chart.
The absolute heavyweight champ of comparison. Simple concept. Rectangular bars, vertical or horizontal. Length shows the value.
Perfect for ranking things, or those straightforward comparisons, like comparing sales figures across different regions, maybe, or product ratings side by side.
Exactly. The strength is obvious. They're just easy to read. Our eyes are good at comparing lengths. But here's a little strategic point that often gets missed, especially with vertical bars. If you have long category label.
The way they get all squished and rotated.
Right. It looks awful and it's hard to read. In that case, flip it. Use a horizontal bar chart. Labels have plenty of space. Clarity is maintained. That's the whole point.
That makes sense. Comparing, say, North American enterprise sales to APAC mid-market solutions, horizontal bars are your friend.
Definitely.
But the limitation is clear, too. They're built for those distinct, countable categories. You can't really use them effectively for continuous data like temperature changes or showing how things are distributed.
No, absolutely not. And that limitation brings us straight to possibly the most globally misused chart type ever. The pie chart.
The pie chart. Everyone knows it. Everyone maybe overuses it.
Often, yes. They have one job and only one job.
Yeah.
Showing composition, parts of a whole, how things slice up into percentages.
Like that classic example illustrating a marketing budget.
Yeah.
Digital advertising makes up 41.7% of the total spend. You see the slice, you get the proportion instantly.
You think you get it instantly. But here's where the sources really hit hard. Pie charts often fail because of how our brains work. We are great at comparing lengths. That's the bar chart strength.
Okay.
But we are notoriously bad at accurately comparing angles and areas, especially when they're similar sizes.
Right. If you have one slice at, say, 15% and another at 16%.
You probably can't tell which is bigger just by looking. You have to read the label. The visual itself fails its primary purpose of quick comparison.
So the takeaway is, if your main goal is comparing different segments, just use a bar chart. It's clearer.
Almost always, yes.
Maybe if you just want to show that one or two big slices dominate the whole thing, a pie chart works.
Possibly. But even then, the best practice suggested across our sources is keep it simple. No more than, say, 5 to 7 categories max. Otherwise, it just becomes this cluttered, unreadable mess. Visual mush, as you said.
Okay. So respect the limits of the pie chart, or better yet, often just avoid it.
Pretty much. Once you need more detail than a very simple parts of a whole overview, you really have to move on.
All right, let's pivot then. What happens when our data isn't in neat categories anymore, but we need to track flow or momentum or changes over time, continuous data?
Yeah, a whole different beast. And the go-to tool here is the line graph or line chart.
The classic for trends.
Absolutely. It's the tool for time series data, showing trends, volatility, how quickly things are changing, velocity.
So tracking stock prices over years, or maybe comparing website traffic month by month for, say, 2023 versus 2024, and maybe projecting 2025.
Perfect use cases. The line graph tells that story of momentum, of trends over time, really effectively.
And its strength, I guess, is also in that visual forecasting aspect. You can almost see where the line is heading next.
Exactly. It lets the audience intuitively grasp the potential future direction. Plus, you can often overlay multiple lines, multiple data series, pretty easily as long as they share a common scale.
But there's a dark side, right? The sources mention a critical warning about how easily they can be misused.
Oh yeah, scale manipulation. It's the most common way line graphs are used to mislead.
How does that work exactly? How can changing the scale actively deceive someone?
It's usually about the y-axis, the vertical one.
Hmm.
The most common trick is truncating the axis, basically, not starting it at zero.
Uh,
So imagine your company sales fluctuated between, say, 90 million and 100 million over a year. If your y-axis starts at zero, the line graph will look pretty stable, relatively flat.
right, because the change is small
Yeah.
compared to the total.
If you chop off the bottom and start that y-axis at, say, 85 million, suddenly that 10 million fluctuation takes up most of the chart's height. It looks incredibly volatile, dramatic peaks and valleys.
Wow, same data, totally different visual story.
It's visual deceit, plain and simple. So, a key takeaway for you, the listener.
Okay.
Always check the baseline on the y-axis of a line graph. Is it zero? If not, why not?
That's a really powerful practical tip. Okay, so line graphs for trends, but watch the axis. Now, what about another chart that uses bars, but for continuous data? The histogram. Our sources were adamant. This is not a bar chart.
Absolutely crucial distinction. A bar chart compares distinct categories, apples and oranges. A histogram shows the frequency distribution of one single continuous variable.
Okay, break that down.
Instead of comparing, say, sales in region A versus region B, a histogram shows how many data points fall into specific ranges, or bins.
So it's about the shape of the data itself, like how spread out is it?
Precisely. Think about employee salaries. A histogram wouldn't compare individual salaries. It would show how many employees fall into the $40,000 salary bin versus how many fall into the $130,000, $140,000 bin, and all the bins in between.
Gotcha. So its strength is revealing that shape. Like, is the data clustered in the middle a normal distribution? Or is it skewed, maybe with a long tail to the right? Or does it have two peaks, like bimodality?
Exactly, insights you just wouldn't see in a table of numbers.
Mhm.
But it has a very significant technical limitation.
Which is?
The choice of bin size, how wide you make those ranges, is kind of arbitrary. And changing the bin size can fundamentally change the story the histogram tells.
How so? What happens if the bins are too wide?
Too wide, and you smooth everything out. You might completely miss important details like those multiple peaks we talked about. It just looks like one big lump.
And too narrow?
Too narrow, and the chart becomes really jagged and noisy. It looks like random fluctuations, and you lose any sense of the underlying pattern or central tendency. It just looks like static.
So you need enough data points for it to be meaningful, and you have to be really thoughtful about picking that bin size.
Yes, it requires care. The tool designed to reveal the data's shape can actually hide it if you're not careful.
Wow. Okay, that's a serious caveat. So moving from distributions, let's get into relationships between variables. Section 3. Starting with a real classic, the scatter plot.
Right, scatter plots are where we usually go when we have a bivariate data. We're looking for a potential connection or correlation between two continuous variables.
Like, does spending more on advertising relate to higher sales revenue? That kind of question.
Exactly. Or is there a relationship between hours spent studying and the final test score? Or height and weight. You plot each data point based on its value for both variables.
And then you look for patterns in how the points are scattered, right? Do they clump together? Do they form a line, maybe sloping upwards or downwards?
Precisely. And if they do seem to form a line, you can often overlay a trend line, which helps visualize the potential relationship and can even be used for basic predictive modeling. That's its strength, revealing those hidden linear patterns that aren't obvious in just a table.
But, and this is a big but, the sources stress.
And the absolute crucial caveat, correlation does not imply causation. We have to keep saying this.
Just because two things move together on the scatter plot doesn't mean one causes the other.
Correct. Think of that classic, almost funny example. During summer, ice cream sales go up, and unfortunately, shark attacks also tend to increase. A scatter plot would show a positive correlation.
Right. More ice cream, more shark attacks. Seems linked.
But obviously, eating ice cream doesn't cause shark attacks. There's a hidden variable, the warm weather, that causes both more people to swim, increasing potential shark encounters, and more people to buy ice cream.
So if you try to reduce shark attacks by banning ice cream,
You've completely misunderstood the correlation shown on your scatter plot. You have to be really intellectually honest about what might be driving the relationship you see. Scatter plots are great for exploring potential links between two variables, but they don't prove cause and effect.
got it. Correlation is not causation. Check. Okay, what about something much smaller visually? Spark lines.
Ah, spark lines. The ultimate in micro-visualization. I love these for dashboards.
Yeah, they're so efficient. You often see them embedded right inside tables or next to a key number.
Exactly. A sparkline is basically a tiny stripped-down line chart. It's designed to be embedded in line, right, with text or in a table cell. It gives you immediate trend context. Is the number going up, down, staying flat, but without any axes, labels, or grid lines.
Super space efficient, like those little trend lines you see next to stock tickers.
Perfect example.
Yeah.
Or maybe next to a key performance indicator on a business dashboard. Just a quick visual hint of the recent trend.
They seem to tap into that pre-attentive processing idea. You don't consciously study it, you just instantly get the direction.
That's the idea, that high-density immediate context is their biggest strength.
But that strength must come with a trade-off, a limitation.
Of course, zero precision. They give you the general shape, the direction, but absolutely no detail. You can't compare specific values. You can't see subtle changes easily. They are purely for that quick general trend indication. If you need details, you need a proper chart.
Makes sense. Good for a glance, not for analysis. Okay, this feels like a good transition into section 4, where we're dealing with bigger, more complex data sets and need tools specifically for spotting patterns. Let's talk heat maps.
Right. Heat maps are definitely stepping up the complexity. Think of them as a matrix, a grid. You're usually mapping relationships between two categorical dimensions, but using color intensity to represent a third quantitative variable.
Okay, so 3 variables packed into a 2D grid using color. That color scale sounds critical. What are some powerful use cases for this?
They are exceptionally good for finding patterns in really large, complex data sets where other charts would just become a jumbled mess.
Like what kind of patterns?
Well, a classic example is sales performance. Imagine a grid with products down the side and months across the top. The color intensity in each cell shows the sales volume for that product in that month. You can instantly spot which products are consistently strong sellers or which months are best for particular items just by looking for the darkest or brightest colors.
I see. So you can scan a huge amount of data quickly for hot spots or cold spots.
Exactly. They're also used a lot in things like website analytics to show where users are clicking most often on a page, literally a heat map of activity. Or in biology, for gene expression data. Anytime you have a big matrix of values and want to see patterns or correlations quickly.
So the strength is pure pattern recognition in complex, often multivariate data, finding outliers, finding dominant intersections.
Yes. But the limitation is tied directly to that reliance on color.
How so?
Well, first, interpreting that third dimension using only color puts a significant cognitive load on the viewer. It's not as intuitive as length or position. Second, the choice of color scale is everything.
What makes a good or bad color scale?
It needs to be intuitive, often sequential or diverging. If the colors don't map logically to the data values, like randomly assigning bright red to a median value, the whole chart becomes misleading or impossible to interpret.
And there's the issue of color perception too, right? Like color blindness.
A huge consideration. You have to choose color scales that are robust to common forms of color blindness, or you risk excluding a portion of your audience from understanding the data at all. So careful color selection is paramount.
Interesting. It really does seem like the more complex the visualization tool, the higher the risk of it failing, if not used expertly.
That's often the case. Power comes with responsibility. You can
And just quickly, the sources mentioned a couple of other specialized charts, box plots and network diagrams.
Yeah, just briefly, box plots or box and whisker plots are fantastic statistical tools. They summarize the distribution of a variable median, quartiles, outliers, and are great for comparing distributions across different categories. Think comparing the spread of test scores for different classes or delivery time variations for different shipping companies.
Okay, focused on statistical summary and comparison and network diagrams.
Those are for when the connections between data points are the main story. Visualizing relationships, flows, networks. Think social media connections between users, mapping financial transactions, or illustrating organizational structures. They tackle relationship data that standard charts just can't handle.
Got it. Specialized tools for specialized jobs. Okay, this brings us to probably the most critical part. Section 5, the decision framework. We've seen the tools, we know their strengths and weaknesses. How do we actually choose the right one? What's that know your data checklist we need?
It really boils down to asking yourself 4 key questions before you even think about making a chart.
Okay, number 1.
First and most fundamental, what type of data do you have? Is it categorical, distinct groups? Or is it continuous measured values on a scale? Getting this wrong is the root of many bad charts. Using a pie chart for continuous time friends, like we mentioned, disaster.
Right. Data type first. Number 2.
How many variables are you trying to show? Just one variable's distribution. That might point towards a histogram, trying to compare two variables, maybe a scatter plot or a line graph. Dealing with multiple variables interacting. Perhaps a heat map or stacked bars are needed. The number of variables dictates the complexity required.
Okay. Data type. Number of variables. Third.
This is crucial. Who is your audience? Are you presenting to technical experts who understand statistics and complex visuals? They might appreciate the detail in a box plot or a histogram.
Or is it for a general executive summary?
Exactly. In that case, you need absolute simplicity and clarity. Stick to bar charts, simple line graphs. You have to tailor the chart's complexity to the audience's ability and need to understand it quickly.
Makes sense. Know your audience. And the fourth question.
What is the purpose of this specific chart? What question is it supposed to answer? Are you just exploring the data yourself, trying to find patterns? Or are you explaining a clear finding to someone else, making a specific point?
How does that change the choice?
Exploration might allow for more complex or unconventional charts while you dig around, but explanation demands clarity and focus. The chart needs to deliver one message effectively. Purpose defines the required level of visual rigor and simplification.
Data type, variables, audience, purpose. That's a solid framework.
If you answer those 4 questions honestly, you're already halfway to choosing the right chart, and it leads directly into best practices.
Like what? What are the big do's?
Always start simple. Can a simple bar chart tell the story? Use it. Don't jump to complexity unless necessary. Ensure every chart has a clear purpose, answers one specific question, label everything clearly, axes, titles, units.
And the big don'ts. Avoid chart junk. I like that term.
Yeah, coined by Edward Tufte. Chart junk refers to any visual element on the chart that isn't conveying data information or isn't necessary for understanding.
Like what specifically?
Excessive grid lines, distracting background images or textures, unnecessary shading or gradients, overly complex legends when direct labeling works better, and the absolute worst offender, unnecessary 3D effects.
Oh, the 3D pie charts or bars?
They're terrible. They add zero information, they distort perspective, making it impossible to accurately compare values, and they just clutter the visual. They destroy clarity for the sake of faux sophistication. Avoid them like the plague.
So the main errors are things like those 3D effects, messing up the scale like we discussed with line graphs, using distracting junk, and fundamentally just picking the wrong chart type for the data you have.
Those are the big ones that kill clarity instantly.
Okay, so wrapping this up, the core takeaway from this deep dive seems to be that good data visualization isn't just about aesthetics, it's a strategic communication act.
Absolutely. It demands that you prioritize clarity above all else, ruthlessly. Match the chart's complexity to your data structure, your audience's needs, and your specific purpose.
If you make those strategic choices, your data starts to speak clearly instead of just adding to the confusion.
Precisely. It transforms from noise into signal.
So, here's a final thought for you, the listener. Now that you know the specific job requirements for each of these visualizations, the comparative power of the bar chart, the trend spotting of the line graph, the distributional insights of the histogram, the pattern finding of the heat map,
And all their limitations and potential pitfalls.
next time you encounter a chart, especially a complex one, ask yourself, what specific question do you think the creator was trying to answer with this visual? And, thinking back on our discussion today, did they actually choose the right tool for that job?
It's a great critical lens to apply. You'll start seeing charts very differently.
We'll let you chew on that. Until next time.
Keep diving deep.
Thanks for joining us on the Deep Dive.